Okay. Hi, everyone. Welcome to another episode of the Common Lisp Study Group. I'm your host, Ron Baden with Atlanta Functional Programming. My apologies to my viewers. Last week, we had some technical difficulties related to connecting uh, the Jitsi application over into. We use Jitsi here at the Common Lisp Study Group to connect to YouTube to do our live streams, and there were some uh, difficulties between connecting that in order to actually run the live stream correctly. I had to spend quite a bit of time to try to figure some of this out. I think I've managed to resolve the issues as it looks like we're now back to being able to actually share my screen while actually talking over the stream. Uh, so I thought I would begin today's discussion with the kind of conversation we left last week because I was unable to actually run through some of the stuff that we would want I wanted to kind of discuss last week. So to get everybody up to speed, prior to the last couple of weeks, as we were covering graph databases using the cl-neo4j Lisp API. It's a wrapper library that was on top of the cl-neo4j HTTP API for actually running cipher queries and inserting nodes and interacting with the graph database in general. However, we discovered as part of our um, exploration of that library a couple of weeks ago that the HTTP API actually changed as a result of Neo4j, I believe the 4X series. They're on the 5 series right now. And that mainly was involved with getting rid of the node relationship REST APIs that they were particularly uh, they introduced as part of the old REST API and replace it with an actual transaction API as part of their efforts to make Neo4j ACID compliant. So I created a somewhat primitive version of this API. How we would actually update the library to actually increment this transaction API a few weeks ago, and it ended up having a couple of problems that we were kind of debugging online, and I thought we would discuss um, today how to actually update it and what I found kind of in the meantime of actually what's it what I found in the meantime on what actually the issues were to actually use our function that we created before to actually create nodes and relationships inside the database. Just give me 1 second here. I just realized I forgot to start Neo4j um, because I actually killed it the other day. Um, that works. Um, just check one thing. Um, that I'm able to log in. Okay. Uh, let's call this Neo4j and Neo4j connect. Okay, so it looks like all this is done. Let's see if let me just check one thing here, which is match. Okay, so this is still here. Let me sorry. Okay. Okay. Let's do this. Let me clear out all this stuff. There we go. There we go. All right. So I had to clear up my Neo4j instances a little bit just to get this kind of up and running. So apologies. All right. Let's get started here. First, we need to obviously set our credentials here again because, oh, I forgot to load Neo4j. Let me go ahead and load Neo4j. And we're going to go ahead and make these into a newer API today as part of our discussion. Okay, so now Neo4j is loaded. Let's go ahead and load the ports, set our database to being, oops, that's right. I created a new instance of this in the utilities. Okay, where are you? This is in this Roswell local projects cl-neo4j source. I believe I did have to do it in utilities, right? No, not there. It's in globals. There it is. And just so that next time we don't have this problem, let me go ahead, and I think this needs to become an exported symbol. Let's go ahead and add this. So for folks who are looking at this, these are the global variables that you can set up so you can interact with different Neo4j databases. These uh, by globals, remember these are dynamic variables. Like if you create this in a concurrent fashion, obviously you could do a let form and set this up with some more complex macros to actually be able to switch between databases and different threads. But for the time being, just you could consider them as essentially the equivalent of global variables. Um, Let me just go ahead and add this in the package. Where is Neo4j host? Forgot that I had that. Okay, let me restart this because I would like to make sure that everything is set up correctly. Okay, clear REPL. Okay, let's switch over to my, do this again. Since we were, let me go ahead and reload cl-neo4j. Okay, good, good, good. All right. And let's go ahead and double check to make sure that this request is going to work by simply doing like we did before. We were going to set the header stream to standard output just so that we actually see what um, is being set up for our requests. And let me just run this, and we get a unauthorized, right? Yes, unauthorized. Okay, good. So let's do this, run that. I set the Neo4j password and user in a separate credentials file just to make things a little bit more secure for the sake of our um, discussions. When you set up a Neo4j, you have to actually set up the user and the password separately inside the um, the Neo4j web browser API. Sorry, the web application. When you actually start up Neo4j in the Docker container, it will actually have this like little front end. This is actually one of the reasons why, like I said before in previous discussions, um, you want to open up when you start up your Docker container, or if you're running Neo4j outside in a separate jar file because Neo4j is written in Java. You want to leverage port 7474 for the HTTP application and 7687 for Bolt. We're not going to focus on Bolt yet, but at some point we will extend the cl-neo4j stuff with the Bolt protocol just to make things a little bit more complete for this library. Now that we have everything kind of set, we can now get started. So last week, sorry, the week prior to last week, we created this function, if you recall, which allowed us to essentially talk to Neo4j with what CLJSON has. Neo4j library uses the CLJSON library to encode and decode JSON payloads. And we used encode JSON A list a string to take an associative list to create the actual structure of the transaction API, as you saw here on line 26, which basically is a JSON object that creates that takes one or more cipher statements, where each statement can be kind of like a prepared query, which we could see shortly. And that prepared query is, or it's a fixed query. So you have the statement with cipher, your cipher query, and optional parameters, and these parameters will be substituted into the cipher query and the server side. So you can have these prepared queries created and you can reference variables inside of it just like SQL does, and you can actually go ahead and pass the full payload to tell Cypher what to inject into those representative variables inside the prepared query are before submitting it for query execution. What we encountered was is once we created this this node, you may have noticed that here, if you recall, that if we try to create, say, uh, a uh, a um, a node where we and again, the node name right now is containing the node type too as well, which I will shortly talk about when we start talking about Cypher a little bit more detail. Um, and we allowed to pass in some metadata regarding this uh, uh, this uh, particular node. You'll end up you may have recalled that we ended up getting something like this, all right, where it basically said it was okay, but it provided kind of like an error, right? Now, nice thing about cl-neo4j's architecture is it actually uses flexi streams, and flexi streams has this API octet to string that we could take the previous example to see what the JSON root format is. And we see actually that the results is that we didn't actually insert a node in the graph. Okay. Um, and it tells us clearly here what the issue is. The client error request invalid format, unable to deserialize, expect start object, file object, start array, and found start object, field name, whatever, right? And that's telling us that the issue is actually with uh, the um, the payload, the actual JSON payload. So one way that we were able to take a look at this is to simply take our JSON to string, okay, and run it in the REPL. And actually, I could do that without doing this. So do this, MCR, and you see that no name is not bound, right? I have to actually do this. Let me do that. Paste it. Let me go ahead and change this to dtest movie and convert this into our list dtest and released 2000. And we will see that what's the problem is it's expecting, let's break this down a little bit. It's expecting the start of the object, which tells us the state, is the a start of a JSON object, okay? A field name, which is telling us that it's expecting statements, and then start array is saying that it's expecting, as you can see here in line 26, it's expecting a JSON array of um, JSON objects, okay? And what we actually created was, if you see here, is we created a JSON object that contains a field with another JSON object. So it's a nested JSON object. Okay. So we need to correct this. All right. Now I tried to actually do some experiments to actually get the A-list to kind of working. And long story short, A-list is very limiting in how it can be encoded into JSON. And this is not a criticism or a limitation of A-list specifically in terms of its use. It's just that we're trying to overuse it for multiple purposes. And on the JSON side, since A-list has very limited representations, um, it can't necessarily determine what would be considered to be an array versus something that could be just a simple list that's getting converted into an object. Okay. As you can see that on line 42, that's exactly what we're using. We're using a list to create statements. And that's what's the JSON encoder is actually being used in this encode JSON A list to string function that converts that list to a JSON object, not actually an array. All right. So to fix this, we're going to have to go a little bit more, slightly more complicated, but not too much of it, too much. And that begins with creating a class called cipher transaction. Okay, we're essentially going to encode the JSON format that contains statements of multiple cipher statements. Okay, for a transaction, and we're going to use cl-JSON's ability to actually go and easily convert these objects into the appropriate um, JSON property. All right. Now here, cipher transaction is going to take statements. Obviously, I don't need to explain the Lisp object syntax here. The one thing I will point out is I created not just a statement init argument, but I also set the init form to being the empty list. Okay, and this actually is kind of a way of telling the JSON encoder that this is going to be kind of it's going to represent a JSON array. All right, because it's treating lists as arrays. The next thing is we have to create, like I said, if we recall, and let me bring this here for our purposes. For the each individual statement with parameters, this is going to represent a single cipher query. All right. And so um, this right here represents a single cipher query. So I went ahead and created a separate object called cipher query that takes the actual cipher query statement and the optional parameters that may or may not be available when you create them. All right. So um, obviously, we have these two things here. Let's go ahead and add them. For construction, I created a make cipher transaction. So this way you don't necessarily constantly call out make instances because this could get constantly a little bit unwieldy if you're especially making multiple transactions sometimes. Um, so this constructor and the next constructor are basically for creating um, our cipher transactions and cipher queries respectively. Finally, we created a function called create node query. Okay. And create node query is actually creating the actual cipher statement, okay, that we had before. Okay. And this actually goes ahead and takes node name, node type. So let me go ahead and correct this. Node name, node type, metadata. So this way we have a that takes in and converts and creates a proper cipher statement for us. So let's see how this works. This one, it should be pretty obvious. Obviously, if we do create node query and we say the test, we say the node type is movie, and we say the node properties is title, the test, and released 2000. Okay, you see that it will create our appropriate cipher query for us the way we expect it to. Okay, so we now have all of our pieces together to actually go and convert this into a proper cipher query node. now we can actually call out to tx commit. Okay, very important. Um, tx commit being available. Um, and just do one thing here. Uh, there we go. And let's go back to this. All right. So now we can actually go ahead and do create node again. And again, we're going to update this to also provide the node type. And we're going to pass the node type here. So now what we have is our updated version. And I'm going to go ahead and split the screen here so that you folks can see the previous version and the newer version. So this is what we had before. Okay. And this is what we have now. So we've expanded our Lisp function that takes in node name and node properties to have node name, node types, and node properties. Okay, that's a slight aesthetically thing, so to make it a little bit more generalizable. But the important thing is the HTTP request difference. Again, we're still passing it over to tx commit because if you recall uh, our discussion when we first created this function a couple of weeks ago, the issue was the fact that transactions, when you open up transactions using TX and do a post on a TX directly, you're actually opening up a transaction with an expiration date. You could create one or more transactions when you are talking to cl-neo4j, and then you could use the commit to actually go and automatically commit all those multiple transactions. Okay, we'll see an example of that when we create a generalizable version of this to actually allow you to create transactions inside the Lisp wrapper. Because right now, today, I'm just focusing on single queries, or in this case, really ad hoc queries that you would probably run as part of just generally querying a database that's currently available. Okay. So by the way, this create structure here could take multiple queries, and we can also actually deal with that too as part of the example later on. We probably can create a generalized function for that too. So what we're doing here is we're just creating a standard, you know, this here is something that we did last time. We created a standard HTTP request to our Neo4j database. We're saying that it's a post transaction. The authentication, all Neo4j requests require you to um, uh, uh, what's it? Provide basic authorization for authentication, basic authentication as part of the HTTP request to connect to the database so that you can actually see it. So that it knows that you are authorized to actually go and insert statements or run queries against that database. The next thing is and this is the more important part after we created the application type based on these are all the same things that we had before. This is the main difference. Instead of doing encode JSON alias to string, we just use encode JSON to string. And what encode JSON to string does is and this will be more important, is that it takes a Lisp object and will then convert the actual returning object instance into the appropriate JSON transaction. Interestingly, this piece has a decode JSON piece too as well, and that decode JSON could also convert and construct the object that you have assuming that the objects are as part of our intern symbols inside of your Lisp image. So this becomes very useful for the design of it. And then now we can actually create our transaction. Now the transaction here um, takes one or more statements. Each of them can be their own like cipher queries. So like here we have a make cipher query object that takes in the create node query function that we created. And what this is actually doing is it's taking, if you recall, here, let me just do this. Um, 1 second. I thought I saved that. Okay. Where is that? Yeah. So if you call our create node query, it's actually taking in a statement returning a format, and our make cipher query will actually use that to go and convert and create the optional what is it? The optional statements that it needs to actually create the proper cipher query object that we defined earlier as part of constructing the JSON representation of this as Lisp objects. All right. So let's see how this all works on the command line. Okay. So sorry, on the REPL. Let's do this. This here should be pretty straightforward. This is just constructing some stuff that we've already talked about. And you can see that if we do the test movie and our title, the test released 2000, actually, we're going to make this release date instead of release. Okay. And you can see that this creates this cipher transaction that if we go and navigate to, it'll go and show us the objects that it has. If we go and navigate to the cipher query object, you can see that parameters is unbound, but create statement is available. Okay, so let's see what this generates when we create a string on this. Okay, so let's do this. There. Okay, we do this and we do cpwr. Oh, sorry, cpwr. There we go. And we do cl-json encode JSON to string. You'll see that it generates what we kind of what we expected. Okay. Now, a couple of things. Obviously, for folks looking immediately, you're wondering why these nodes are metadata nodes are capitalized. That's mainly because that's a consequence of the associative list keyword symbols. When they get copied over and encoded into JSON, the keyword symbol of them gets capitalized. So there isn't a clear way for me to construct something that would potentially lower this without creating an actual object that represents these nodes, which we could certainly do, and we could probably extend this API um, uh, to allow people to take objects. But keep things simple for the cl-neo4j update, we're going to go ahead and um, keep it has a set of node properties that can be passed in as an associative list. Okay. Let's go ahead now and run this guy. So update, we created a node. So now let's go ahead and do this, test movie, and now, now obviously I could put any movie right now. I'm just putting some dumb example name just because I can't think of any particular movies that I'd like to add right now. But let's say 2000, and we get, and let's see what our flexi streams octet to string tells us. Oops, sorry, string. There we go. Syntax error, invalid input. Let's see. Yeah, I don't think it liked the fact that I put yeah, it didn't like the fact that I added a I have to use like a underscore instead of a slash, and that should work. See, results, columns, blast bookmarks. Yep. Okay. So this looks like it got inserted. Let's go ahead and first check to see it in our actual API, shall we? The web browser, that is. Give me a second here. Let me share that screen. Window Neo4j. Okay. And we can see that if we run a match query on this, match a movie, return a, and you can see that here is the test movie. You can see it as part of a table, although it's not really a table, it's a JSON object. And for folks using the query database, this is how it will look like, what text, and one of the nice things about the Neo4j browser tells you what query you ran, the summary, and what is the actual responses of it. Okay, so that's pretty cool. We figured out how to create stuff. We've also know how to technically run selects, but we need to add selects in and uh, and things like this. But before we do that, let's try and see if we can add this API into cl-neo4j proper, shall we? So one way of doing this is and if the author of cl-neo4j is watching, um, I am planning on making a formal maybe request of this information. Um, so I will. You could reach out to me if you are um, if you're on GitHub, um, uh, and or I actually am Bugram on the functional programming Slack channel, as well as on the Lisp Discord server too as Bugram. And I'm available on both of those platforms. Anybody who wants to reach out to me can do so as well. So this is kind of my attempt of how I might actually go and extend the API to deal with transactions. Um, we could certainly go ahead and create our own version of this, but I think it would be useful to add this as part of cl-neo4j, um, just because, obviously that would make things a little easier for folks. There's a single library that has everything that we kind of expect it to have. So first things first is to define the API, okay? Or there's a couple of things that we could do too as well. One is obviously um, extend the current API, um, or update the current API to use the new transaction APIs. One of the consequences of doing that is obviously um, older versions of Neo4j cannot be used anymore. It will be a breaking API change. I don't really like that idea for the time being. Obviously, since it's been deprecated by Neo4j, it is a possibility that you could certainly uh, argue that, well, the newer versions expect us to use a transaction API, therefore we shouldn't necessarily support the old one. But if folks are still using older versions of Neo4j in production somewhere, all right, 3.5, 4 in some cases, because migrations is difficult. The application already has so much data, so moving off of it requires a little bit of a strategy. Um, in those situations, having Lisp's the ability, at least until it's known for sure, would be useful. So what I'm suggesting is first we create a new package inside. Oops, hold on, I'm in the wrong buffer, aren't I? No, I'm not. I'm in the right one. I just am not in. Is as we first go and we add in package a new package called cl-neo4j transaction. Now, obviously, the package name can change before we uh, publish this thing or whatever. But this is kind of my suggestion. Um, and from here, we could go ahead and export our newer APIs. Okay. We can say here, create node. We have and these are all using the new HTTP API. And this behind the scenes is technically doing what we're expecting to. It is creating ad hoc transactions and committing them. So it makes sense to having something like this being available. And what's that? We need to say get node. We'll have okay, for that, I think that's good enough for the time being. And let's say delete node. And obviously, we also want to have this kind of similar thing for get relationship. And sorry, oops. No. I hate when this happens. Get relationship and delete relationship. I'll say get create relation. I think it's actually get. Let me see something here. No, it is called relationship. Okay. Making sure that I'm following the same sort of current things around. So let's go ahead and do that. Order it. Relationships. API. Node API. Okay. And then we can add more, but for the time being, we're going to add these two. And then there are other things here too as well that we can create, like for cursors and things. But this is kind of the basics of this API that we can go through, right? So now that we added this in our things, let's go ahead and create a new transaction.lisp that goes ahead and defines it, shall we? In package cl-neo4j transaction. And before I do anything, it looks like I forgot to actually run this to actually set the transaction. Okay, so here, let's do an MRS. So we're now in our transaction. Recall in Sly, you have the ability to switch packages by doing a set package. For folks who are using Slime, you could do something similar. I'm forgetting the um, uh, key combination off the top of my head, but you could simply go into the Slime REPL and say, I think it's bang P, and that would allow you to set the package by running it in the command REPL if you're running Emacs. If you're doing Space Max, I think MRS does the same thing for Slime. Um, if you use the space bar, so space MRS is going to allow you to use it too as well. All right. Um, Let me go back and switch. Um, Back to my Emacs screen. Give me a second here. It looks like there's a 10-second pause. Hopefully. All right. So we created this new transaction API, create node, get node, delete node for the YouTube viewers. And in what we're going to do is we're going to go ahead and define these now and move our create node query into the local things. Please notice I am not trying to actually export the objects that I've created to represent the JSON payload. That is actually not necessary, I don't believe. So for folks who want that kind of control, my current design thinking is that that's unnecessary. That's actually exposing too much to the end user of the cl-neo4j API. There's no reason for that need to behavior. We should create a Lisp wrapper around those things and be able to accommodate the adjustments that need to be created to interact with Neo4j without exposing the actual query payload itself. And another thing to note is as far as I know, the Bolt protocol that I would eventually extend the Neo4j stuff to include, that stuff is also going to be using, I think, I believe a similar payload too as well. So a lot of this work could be refactored to actually go and put into a common place, and we can certainly do that as part of this discussion. Okay, so let's go back to here and let's go ahead and go to our Neo4j pack scratch buffer, and let's grab these guys here. Okay, and maybe even this all the way through so that we now have our, oops, there we go. Okay. All right, so we now have all of our stuff in the package. We have exposed it. Let's go ahead and actually restart our REPL just to make sure we can actually load cl-neo4j with this new information, shall we? Let's go ahead and restart it. Make sure that this all is done. Clear REPL. Quick load. And transaction is in. Let's see, neo4j dot transaction make create node. Okay, so here looks like create node is actually not getting the kind of smart things that I was expecting, but that's fine. One thing I want to make sure that I add here is creates a node into cl-neo4j database using transaction API, using single transaction. Okay, and in Cipher. Creates a node of type. I think it's important for us to actually add that of type node name colon node type and node properties. So for folks who are reading this, they know that this is generating the actual appropriated node, and this would work. Now, I'm going to say up front that there's a couple things here that we need to clean up after we have all this kind of set up. And it should all be good. Oops, hold on. MRS, there we go. Create node is unbound. What are you talking about? Hold on. Undefined function. These are all warnings, but hold on. I'm gonna have to restart this again. I may have messed this up. Okay. Okay. There we go. Oh. Okay. Now, let's make sure that this still says create node. The variable create node is unbound. What variable is it talking about? There's no variable here. I'm just doing a defun. 1 second. Oh, my apologies. I forgot to do one thing. I keep forgetting this. Clear REPL. Here. I forgot that. I knew I forgot something. I should have done that. And let's do the same thing that this is actually interesting. Let's go ahead and do the same thing here. Alexandria. No. Anaphora. That's actually pretty important as well. So we can actually have anaphoric macros. And, oh yeah, split sequence is important as well. For the now, the goal is essentially this node create stuff. This Neo4j wrapper should essentially be updated to use this transaction sub namespace to actually run stuff. But my first goal is to actually get all of the basics kind of working inside um, uh, cl-neo4j transaction. Um, Obviously, this is a slightly different thing than this because obviously there's stuff here in like node add to index, node remove to index, and stuff like that that I need to add to that transaction stuff, which means I'm going to probably have some duplicate APIs that just being delegated inside the wrapper. But my goal is essentially eventually move some of this stuff into the cl-neo4j wrapper once we've done a lot of this work in kind of isolation, and then see what stuff can be updated safely and what can be would require us to create a new uh, exposed transaction API through the Neo4j wrapper. All right. So this here, I don't think I need anything from Neo4j specifically. Do I? No, I do not. Just make sure of something. Requests. I believe it's in requests, right? Nope, not here. It's in REST API, right? Yes, there we go. So I need to eventually move this stuff over to follow kind of the same sort of structure that the author created for creating these new functions here. So yeah, that's fine. Okay, so I can use cl-neo4j and then get some of these utilities. Okay, let's see here. All right, so where is this guy? These are all utilities. Where is def macro? The Neo4j macro buffer that he created. Let me see. It's not in globals. Maybe it's in query. Ah, he already created some of the stuff. Okay. Okay, I just learned that he had some of this already. Structure cipher queries. I mean, he didn't need to do that. Um, he could just do make instance and he would have been fine. Um, that should have been a optional properties. Um, okay, I can move some of my stuff over to this guy and that would still be pretty safe. Um, mhm. Okay, so what I'll do is I can add new design. Go back to transaction. Um, this guy here no longer is needed necessarily. What we'll do is we'll move this stuff over to as well to here. And technically speaking, this I don't think is needed. But why does he have a step method structure cipher query? Those properties are optional. This I would make optional, but this would break an API, break the API. Um, I would, yeah, it looks like he has some of this information done if you wanted to run multiple queries, but the way he designed it was a little confusing and I just didn't notice it. Let me see this. This is, let us do table. Okay, I need to check one thing. I need to see in cl-neo4j source, encode cl-neo4j JSON payload. Okay, and here we have Okay, so the way we would want to probably accomplish this is is to update his API is create a new um, extension to the encode Neo4JSON payload, and then create transaction APIs around what he's done to essentially do equivalently the same thing. And this way we can actually go ahead and support both APIs. I believe. We'd have to test some of this up. All right. Do this. Quit. Do this. Okay. Okay. Let's go ahead and first make sure this is saved. Let's first go ahead and develop our stuff in isolation, but we'll try and see if we can do the overrides correctly. So this way, we're one step closer to be truly integrated with the Neo4j extension. All right. But this would require me to probably put tx because of no. We could do transaction create node. That will be an exposed thing. And then Neo4j. Let's see what happens here. Alexandria is on a package. Oh, right. Never mind. Sorry. I forgot to do a quick load here. QL quick load cl-neo4j. Boom. Now we have it. Okay. This is work. Go to transactions. We have our stuff. We have our updates. Oops. RS. Oops. Sorry. Okay. So let's see what happens when I do it this way. Create node. Let's say we're calling the matrix with the node type movie and the properties title the matrix. Oh, the matrix. All right. And I believe it was released in 1998. So now create node queries undefined. Okay. So let's go to this here, create node queries. That's undefined. Why was it undefined even though it was generated? Hold on 1 second. Okay, so the problem here is that since cl-neo4j.transaction is using, this is kind of there's a name conflict here that's happening. because we did use shit. Okay, so hold on, let me restart my buffer here because we need to redesign the package. Here, instead of saying that we're dependent on this guy, do this, cl-neo4j, okay, transaction, here, rs, okay, that, why is it undefined? Hold on 1 second. Fine. We're going to go ahead for the time being, make these all tx. Okay, let's do one more restart here and clear. There we go. Oh, wait, I'm an idiot. Restart. Clear. Go up here. I have to go and change. There we go. Now, right? Yeah. Good. Now, MRS. TX, create node. Now, okay. So now let's go up 2 levels and say TX create node. Still says that it's undefined. Why is it saying that it's undefined? It's defined in the package, right? Okay, hold on 1 second. Let me do this. Nope. My apologies, folks. I'm just trying to come up with a pretty decent design for this, but this is the for whatever reason the symbols aren't actually getting defined, even though I loaded it in the package. Which is weird. Okay. Weird. Okay, so this is all set up. Let me see if I do cl-neo4j transaction. Okay. It's an exported symbol. Now, we should be getting some errors related to the fact that we're not using cipher queries here. And we're hiding it. But it looks like it's boiled down to naming issues. Let me see if I can add this shit directly to. Apologies for my swear. Let's go ahead and add these transactions to this way. New design idea. We're going to get rid of. I know I've been restarting my Lisp several times, but you know, sometimes when you're creating an API, you have to do this. But let me. I have a better idea. I just got a better idea to incorporate this without fighting the current design that was created here. Okay, so what I'll do is for the time being, all my transaction changes are going to be added directly into the core library. This may not be the best way to do this. Folks who have better ideas, I'm all ears. But I'm trying to make sure that I prevent actually getting rid of the old API just for backwards compatibility for the time being. So here I'm going to have to do kind of similar to what he has here. Create node, get node, delete node. So let's grab these three. Okay, so this is all done. Let's go ahead and now add this to this. Okay, so we've created essentially three new things. Let's go to where create node is being generated, which is the REST API here. And we're going to go ahead and create, which we tried to get tx node. So we're going to do tx create node instead of get tx node for the time being. And there. And we're going to do post. We're going to say node ID node type, node properties, because it's going to be this create node should be have the ability to allow you to provide a name for the node. For some reason, it didn't provide a name for the node. Now, in his expansion, hold on. Let me do meta dot. I think it's meta dot, right? No. 1 second. Where is this function defined? Gotta go to, sorry, this e shell grep rn def neo4j fun det. Okay. Shift def macro request. That's what I was looking for. Let's do slide. Okay. So he wrote, the author wrote all these neo4j functions, and he created this macro that for some reason is not actually giving us a macro expansion. But I'm hoping that I can get request to tell us where neo4j is. And it's defining this as the URI spec and makes neo4j request. Neo4j request basically goes in and converts it into the handle request. And the handle request is what's actually generating what we need for the different things. So what we need to do is we need to make sure that the URI spec that it leverages tells us what that we're doing a transaction commit, and then we can convert things behind the scenes. Okay. Let's see if this works. Okay. Okay. Let's do. Let's do this instead of, because I think this was using create node. Here was using node tilde a. But create node doesn't need to do this anymore. Just needs to follow that. So we just need to follow this guy. And this is going to become technically, all of these are just going to be the same node. So there's room for commit changes here. Let me see if this works actually. TX reverse node is bound. Well, that's because that wasn't updated. Alexander, oh, QL quick load. I forgot to load my package. That's the reason. Okay, now let's see what this looks like. All right, so this is creating the cl-neo4j request, and this guy is a function call, if I remember. Okay. The only problem here is this is not matching our previous design, because although this is creating a proper thing, their cl-neo4j request does not use the node type. It doesn't split it to this level of granularity. So let us, and this is because it's again, this node API, for folks who are looking at this, the node API is actually a RESTful API. So when you're creating a new node here, it's going to generate the hash representation of the node for you. Okay. But when you're dealing with the transaction API, you need to pass that hash representation back as part of the actual JSON payload. And in fact, you don't necessarily need to know it, because the transaction API will take care of the deserialization and uniqueness and all that kind of stuff for you behind the scenes. So some of the stuff that was designed here was based on the assumption that we are dealing with a proper REST API, as indicated by the Lisp file that we're modifying. So it looks like that in order for me to actually update this, I'm gonna have to actually set up the same infrastructure for that he has for the old API, but for the new API. So we're gonna have to create kind of like a new def neo4j function macro to get the same kind of structure that we have here. Um, mm, and we will see how this might work for relationships and for other things as well. Uh, so let's go ahead and try that. Let's go ahead and create that macro. Let's go, sorry. This is where we are generating this macro, this def neo4j macro. Let's go ahead and create a new def macro, def neo4j tx function. And we have a name, we have a lambda list too as well, just like that. Rest arguments. And because we have type and then we have type, we have node type, we have node properties, we have relationship type and relationship properties. We should be able to do kind of the same thing that he's doing here, just like the RESTful API, but we can adjust it just slightly by encoding the URI always being the transaction commit for stuff now, and then when we create actual transactions, we'll end up having to do a post call and then do all the other stuff. So these are all ad hoc transactions that I'm creating now, and in a subsequent episode, we can certainly go through and handle the other aspect of it. So let's go ahead and do that. Again, this is going to be the same prog-end that he has. And the same structure for defun is going to be the same too as well. We have the name, and we have our lambda list. Okay. And here, what I'm going to do is instead of getting the URL spec, because this, let's see here, handle request handler. These are all request handlers, basic handlers. Well, let's just work through this one at a time. I think a lot of this can be matched, but the only difference is the URI is going to be fixed to always being the transaction URI. But everything else is kind of the same. So there might be a situation where we're going to have some code duplication here, and then we're going to have to do some refactoring. But we'll see what that looks like. He's using anaphoric macros here. So let's see. Let's grab this here. Get the same. Oops. Okay. Okay. So here, I believe all I would need to do is just do now method URI is going to be a transaction function for commit. And really it should be tx commit. The name of this should be a transact commit function or ad hoc transaction function. Let's say def query function versus def tx function. And that should work. That should be the same stuff. So let's see if this actually is going to do what we expect it to do. Go here, go here. Let's add, I think def cl-neo4j. Is there? No, it's not there. Okay. Okay. Query function. Okay, what is it complaining about in here? It is complaining about JSON is defined but never used. Uh-huh. Okay. Let's see something here. How did he end up leveraging this here? He's using an anaphoric macro to actually go in and inject the JSON object, but I don't believe it's, let's go back to node here. Okay. Ah, so it is being used. URI is defined but never used. Well, that's true. That's because of the oh, node type warning, node properties are not used. You see, we need to go in and add this stuff into our version. So we're going to probably have to create a mirror function of what is there to get kind of a similar behavior and a similar structure. All right. Okay, so let's go back to not this request. Here we go. Okay. Encode JSON payload is the problem. We're kind of expecting it to always be mm-hmm. Can we do this without a this conversion here is the problem here is this anaphoric macro. This is trying to see if we have something called encode, and based on the encoding, it will call the appropriate override. So like if it's an object, it'll go and call, I think, the generic object default implementation, which is encode JSON to string, which is what we were using before. The if it's a coulter, it was going to uh, grab the otherwise it's going to grab the actually sorry, if association encode args exists, it will take the coulter of the iterator of the anaphoric iterator. Otherwise it will actually treat it as a list of strings to do an encoding of the payload. And we saw earlier in their version in the old API how this is looking like. I think this is a little. This may not be necessary. I mean, it could be necessary, but I currently can't seem to think of why you would want to like. Would you really need to use an anaphoric macro for this? I'm going to try something simpler just for the sake of the time that we have to incorporate this. And if we can't get this in today, we will certainly spend some time next week to actually try to finish this up, and then we could start working on selects, selects and retrievals. This is really just kind of some of the basic functionality that needs to be inside using the transaction API that we're playing with. Um, and we need to get this infrastructure in order for us to add some of the other stuff that's required by this to run different Cipher queries like optional match or return or unwind. Um, uh, but the core of it is the JSON object that I showed you, which is you have statements, which can be an array of one or more Cipher statements with the optional parameters. It's just now a matter of getting this construction inside and incorporated with the current cl-neo4j library. So that way we have what we need to actually run different Cipher queries. So let me try something a little bit different here, which is instead of this doing all this craziness, let's make some blatant assumptions to make things a little bit easier for us, and then we can generalize. Um, because this is a little difficult to kind of follow along. So we have the name, we have the Lambda list. Let's go in and now so we're always going to assume that it's JSON and things. So we're going to make a new URI. Hold on, actually, hold on 1 second. Let me just look at this one more time. Instead of this, let's just say that we do this. Cut this, and we just say args. Okay. Now, here, redefining the macro, go here. Let's see what the macro expansion looks like. Okay. Tx commit post JSON. Okay. So we're not actually encoding anything here. Okay. Let me go look up this create node for a second to see the differences here. Payload property string. Create node. Payload property string. Okay, so the second half is actually okay with this. I'm okay with this. It's the first half that's a little bit problematic. Shift G, do that. Because what I'd like to do is be able to create a function that then allows us to generate the node type and node properties. Because he's just assuming that we have node properties here. this design. So I'm going to have to change how that's going to be constructed. So, okay. Okay. All right. Okay. Since we know that the construction is going to be something of the form create some node name, node type, followed by node properties, we're going to have to, or even in match, we have match with node var, node type, optional node property vars, I think, if I remember correctly. We have to be able to construct queries such that the appropriate generated cipher queries get created. I don't believe I see anything related to cipher specifically in this framework. So I think what I'm trying to do is essentially attempt to make something, extend something that doesn't have the necessary infrastructure. Like it has everything I need to make requests correctly, but I don't think it has what I need in order to make multiple cipher requests. Let me go back to the RESTful API here because it's using shortest path, it's using get path, it's using max depth. This here is basically him specifying suggestions to Neo4j to run their queries for navigating through it, but I can't write my own queries. Okay. I see we're running out of time here, so it looks like we're going to have to make another episode of how some of this stuff kind of works. And add the infrastructure to essentially update this the way we kind of expect it to. I may end up just creating another library for this time being and then ask a request to get this all incorporated into cl-neo4j via a pull request or a discussion with the author of this library, and then we can move forward. That way, for folks who are interested, more interested in how we're going to run some stuff directly in Cypher, you folks are not worried about some of these intricate details of extending an existing API, and I can get some answers on what would be good practices for that. Um, so I appreciate all of you for coming today. A quick review of what we saw. And I think it goes back to we've established what we originally had before, which is this query system that's calling on it, and replaced it with the new transaction-based API with a much cleaner structure that's more generalizable, that allows us to actually run different queries that, and we could certainly use this current primitive library to write our different queries and interact with Neo4j certainly. And I may end up just doing that next time, just so that way we can move forward with actually interacting with Neo4j and write some applications with it. But in the meantime, um, I'm going to talk to, or at least try and ping the author of cl-neo4j, the actual library that I want to kind of incorporate some of this stuff that we've been exploring in, and see what would be the best kind of approach to actually go in and tackle that. So, are there any questions from the audience? I see I'm getting some shout outs here in the chat. I appreciate for those of you who are joining us and appreciating the material. Just kind of a reminder, if you like what you're seeing, please like the video, subscribe to the channel, the Atlanta Functional Programming channel, and get more people to subscribe as well. And on top of that, by all means, if there are particular topics that you are interested in seeing, um, please feel free to either post in the comments, or if you are so inclined, and you are a Slack user, I do squat in the Tech 404 channel for those of you who are in the Atlanta area, has Bugram. I'm also in the functional programming channel, has Bugram, as well as the Lisp Discord server. Um, and you could reach out to me anytime, provide your topics that you want us to kind of go through inside the CL study group, and we will accordingly accommodate that. Before I let you all go, just a couple of small announcements that I'd like to do at the end of every episode. Atlanta Functional Programming um, is looking out for speakers. If there's some topic that you want to share, it doesn't have to be Common Lisp related. It could be related to functional programming in F sharp, C sharp, C++, or what have you. Feel free to reach out to me again at the recommended social media channels, and we will accommodate you. And I hope to see you guys next week. Thanks.